Hello friends, and welcome to today's lecture. And this is the second lecture of the big data series. A few weeks back we conducted the first lecture, and apologies in advance for not uploading the second lecture in a quick time. We had some technical issues at the back end, due to which we could not upload the videos in time, but going forward we'll try our best to upload a new video every week so that you can keep up your learning pace. With that said, let's get started with the second lecture in big data. And today we are going to talk about the distributed systems, how distributed systems work, what are the distributed systems, and we will talk about some of the solutions which are there to solve problems using distributed systems. Since this is still the second lecture, we will not go into too much technical depth. We'll still try to just understand the concepts, and as we will progress further in the course, we will get into the hands-on part as well. So let's get started. First of all, let's understand what is a distributed system. So if we look at the definition, a distributed system is a group of computers working together as to appear as a single computer to the end user. To give you an example, when you go to google.com and you hit a query, you submit a query to search something, what do you think happens? Is it only a single computer which is responding to your request, or is it going to be multiple computers? So in this case, the first computer to which your query interacts is also not a single computer, it's a cluster of computers. There are multiple computers which are connected along with each other, who are taking the query in, and then that cluster of computer is actually passing your query to further backend machines, more computers who are working together to provide all the various search results. Because when you search for a query, you will see the all tab, the images, the tab, the videos tab, right? So the whole page is rendered by multiple computers. So at the backend, there is a lot of distributed computing going on. And that's what we mean by a distributed system, that a distributed system has a lot of computers working together to solve a single problem. Now, it's also worth mentioning that when these computers solve the problems, they share the state of the system overall, right? Because one computer needs to know what other computer has done. So they have a shared state. They operate concurrently, means all of the computers can work on some part of the query at the same time. So so two computers don't have to wait for each other, otherwise it will become sequential and we will lose the whole benefit of distributed computing. It may also sound like parallel computing, and to an extent it is a type of parallel computing, but parallel computing is still a bit different and distributed computing is a bit different. One of the other feature of distributed system is that since all of the computers are working independently and they also have a common way of sharing the state, any of the machine can actually fail or can actually just crash without affecting the whole system in general, because in this case only that part of the processing will be impacted which is being performed by that computer which just crashed. And when that computer comes up again, since we have a shared state, it can pick up its previous state and start working again on solving its part of the responsibility. So every computer has its own part of responsibility. This is just to give you a differentiation between centralized systems and distributed systems. So when we talk about centralized systems, we have a single server and we have all the clients connected to it to get the response from the single server. This was the system back in maybe 80s or 90s, I guess, or even before that, when we have a single computer to respond to your queries. But as the hardwares and the computer parts are getting cheaper and cheaper, most of the applications are tilting towards having a distributed setup at the back end. So you can see that in this image that we have a centralized system and then we have a distributed system. We can also try to understand it with the help of a very quick whiteboarding diagram. So let's imagine these are computers and these are clients C1, C2, C3, and C4, and this is server S1. So in this case, all of the clients are connecting to the same server, and if every client is submitting a query, this server is processing all of the queries at once, or maybe processing them sequentially. That's about a centralized system. Now if we look at the same setup in a distributed system, how will that look like? So I'll just draw the clients here again, and let me draw a logical circle, and let's put a lot of circles. Each circle is representing a computer here, and all of these computers are again connected to each other. All possible arrows you can think of will be going on from one computer to other computer, right? So every computer is connected to every other computer, and when a particular client submits a query, it may be processed by, let's say, this computer and this computer, and client 2 query may be processed by this computer maybe. Similarly, client 3 and client 4 can also submit queries to this logical circle, and there would be some sort of a cluster of servers which will be deciding which particular servers are available to execute the request, and they will pick up the request and distribute the request among them. These systems also have to be built into a manner that the request can actually be processed by multiple computers. If the code is written in a way that that two computers cannot execute some part of the request, then it is of no use. So the code also have to be written in a way that distributed systems can use that code. With that, let's go back to the slides. I just explained how a distributed system works, but let's just rewind this whole concept again. So for example, if you have a single machine and each machine has some input output channels, right? The channels through which it either reads the data or either it writes the data. So let's say this machine has 4 IO channels, and each channel can take 100 MB per second of data. So every second it can read and write 100 megabytes of data. And if the data is 1 terabyte, it is going to take probably 45 hours to process this whole data for the single machine. But what if I have 100 machines with the same capacity of 4 IO channels, and each channel has 100 Mbps of bandwidth available? In that case, I can process the same 1 terabyte of data in just 45 minutes. So from 45 hours, you just go to 45 minutes, because you can assign a certain responsibility to each of these 100 machines, and they will execute the task in parallel. So the same task which was done in a sequence of inputs and outputs on a single machine can be done by spreading this whole request to hundreds of machines, where each machine does its part and sends back the response, and then we compile the response and we send the response back. So that's why the distributed computing is very powerful, because you can break up a particular request or a particular task into multiple subtasks and assign each set of computers with that particular subtask, and those computers will only and only perform that subtask and nothing else. That's what actually that's how the distributed systems work. Now this sounds all very good, but the distributed systems also comes with its own set of challenges. The first challenge is bandwidth, obviously, because bandwidth is, you can think of bandwidth as a limitation of the transmission speed. So the data has to move over the network while processing, right? And you can not have infinite bandwidth. The bandwidth will be some number, some threshold. So how fast your request can be processed is limited by how much bandwidth each of your computers can consume or can work with. So bandwidth is definitely something which limits how fast a distributed system can work. Second thing is about the failures. Since we said that distributed systems are a cluster of computers, they are basically a huge group of computers working together towards a common goal. And in this, even if one of the machines fail, still the whole system continues to work and all rest of the machines continue to perform their tasks. So system failures are normal, and as said by one of the famous CTOs of one of the big companies, he says that everything fails, and that's actually true. System failures are normal. At any time, at least roughly 10% systems may be down. This is just a random or general number, that at any time maybe 10% of systems are down. This also can break some part of the application functionality. Now you may be thinking that if this is breaking the functionality, then how can it be a good setup? Imagine the same setup on a single machine. If that machine dies, and if your application is completely running on that machine, then your whole system dies. But in this case, if few of the systems of the distributed network die, then only a tiny part of the functionality of the application is not working. The rest of the functionalities of the applications continue to work. So you have higher continuity in your application. The other part is the high programming complexity, because you have multiple computers, so management of the computers becomes a pain. So it's almost impossible to handle interaction between components, and it's difficult to manage vast amount of code. So the whole management of the different components and how they talk to each other, whether each of the components sent a proper response back to the caller or not, or how they're maintaining state. So you need to put lot of manpower and effort to maintain these systems, and these are some of the popular challenges. So we talked about the bandwidth challenge, we talked about the failure challenge, and there's also a high level of programming complexity when we talk about distributed systems. And how do we actually solve our solutions or build our applications when we want to build distributed systems? So one of the most popular one is Apache Hadoop. Apache Hadoop is nothing, you can think of it as a collection of open source softwares and libraries and utilities, all bundled up into a single framework, which is called Apache Hadoop. And Apache Hadoop is a distributed framework, so it can leverage the power of multiple computers to solve a problem with massive amount of data and computation. It also provides a software framework for distributed storage and processing of big data using a popular programming model, which is called the MapReduce programming model. We will talk about this MapReduce programming model in the upcoming slides, but for now we can just remember that the biggest value proposition of Apache Hadoop is that it has a lot of softwares, open source softwares and utilities, which we can use to work with big data. You remember we talked about the definition of big data in the previous lecture. So you can use Apache Hadoop to work with big data applications using the MapReduce programming model. Now all the modules in Hadoop are designed with a fundamental assumption that hardware failures are common and they are bound to happen. They will happen eventually. And the system, the whole framework, should have the capability to handle these failures automatically. And that's what Apache Hadoop provides you with. It provides you with automatic recovery and healing options as well, so that even if a system dies, even if a particular computer in the distributed system die, Apache Hadoop will make attempts to recover that system and heal that system. That's what Apache Hadoop is in a very brief nutshell. And like I said, we will not go in very much details about Apache Hadoop, because Apache Hadoop is a mammoth. It has a lot of things, and we will require multiple lectures to actually understand each part of the Apache Hadoop ecosystem. So this was, you can treat this as just an introduction, and in the coming lectures we'll go in further details. And at this point I would like to end my lecture with a summary that we talked about distributed systems, how distributed systems work, what are distributed systems, and what are the different challenges we have with distributed systems. And we just talked about Apache Hadoop, which is a solution for building distributed systems. And with that said, I will end this lecture and we'll see you next lecture. Thank you.